Hi everyone. We are, as promised, on day zero. We are starting with day one, and the primary concept that we are taking to learn is Transformers. So, all of you are much aware about this word Transformers because they are the architecture, the basis, all of this generative AI that we are using right now. So, these are first of all, to be very honest, I thought these transformers as the converters that increase or decrease voltage. What? Yeah, and this is genuinely I'm telling you. But then I got to know that this is an architecture on which LLMs are based on. So for day one, what we will be doing is we will be defining the syllabus. So what I want to do here is that I don't want to read books. There are lots of books, there are because there is there is a ton of knowledge on this topic right now. But what, at least for me, I know that it won't work. I'll start with one book, read it for a couple of days, couple of weeks, but then I'll stop. So for me, this is the approach that has worked for me. So what this approach comprises of is basically it's a structure, and it's an inward structure. So what we'll do is we will pick a concept, then we will define its syllabus. We will define its syllabus by inversely breaking it down, and then we'll start from, again from bottom to top. Okay, let me explain you giving an example. Let's say you want to learn photosynthesis. Okay, so we'll start directly with the concept of photosynthesis. Assume that you don't have any knowledge about plants, sunlight, nothing. But first of all, we'll directly pick up some article from of photosynthesis. Then we'll break it down in terms of unexplained terms, or the terms that you are not understood, or the terms that you have not, you don't understand the concepts, or anything. So we'll just break that article in an inverse manner, which will take us to the bottom place where we just need to first start off with knowing what are plants. Okay, then we'll learn about chlorophyll, then the contemporary, uh, then we have to learn about some of the supportive topics like water, sunlight, and any of that. Okay, so this is the approach I'm starting off with. Let's see where it goes. But to be very honest, this is a very time-taking approach, and I don't recommend this to anyone who wants, who is seriously pursuing this as uh, their journey to learn generative AI. This is just an ancillary, because why it is working for me? Because it's an ancillary thing that I'm doing right now with myself. I have 3 or 4 months of time, so this is the extreme amount of time I have allocated to this. So yeah, for understanding this one single concept of transformers, I have set it that maximum upper limit will be of 3 months. It hopefully it should get narrowed down to 1 month or 2 months, but still we will be, for the next 3 months, we will be allocating 1 hour daily for this in this direction. Okay, okay, so now we got the concept, we got the action items, that what we have to do. But what we'll study, we don't have any syllabus. because in a way we are creating a book of our own for this concept of transformers, and there is no index. There is no index page where you will find the topics. Okay, hey, first, yes, you need to understand this derivatives. Then you need to understand this topic A. Then you have to understand topic B, C, D, and then at last, the final chapter of this book is transformers. But there is no index. So first of all, we have to create that index, and that is what I have done in this. Some of the research that I have done, that what are the topics that I would need to done. It's still not done. I almost spent 4 or 5 hours today to create this, but it's not done. So we will have to spend some more time tomorrow. Syllabus. Okay, we will have to spend some more time tomorrow to detailed out, maybe day after tomorrow also. But yeah, first of all, we'll start, crafting the index for us. And then every day we'll pick up one, not every day, but depending upon the time we took. Let's say first day, first chapter, first thing that we need to cover, we need to understand thoroughly is derivatives. So we'll take that concept, we'll understand it thoroughly. Okay, then second thing is, let's say you need, I'm just using an example, you need to cover CNNs, RNNs, then sequence to sequence models, and that sort of stuff. Okay, so first let me give you a walkthrough of what I did. So the simple and first foremost, I know this guy, Jay Alamar, he has written this paper called Illustrated Transformer. It is very good. I guess even a person with little knowledge about data science and machine learning can understand this. The language is very easy, the diagrams and all of are they are very easy to understand. But still, even if you read this, you won't get the actual idea of why all of these are taking place. Like what are like this one? What is encoder? What happens actually in encoder? You won't get an idea. Okay, so that is why we are diving deep. Okay, so this illustrated transformer by Jay Alamar, it referred about attention, which redirected us to this attention model, this sequence to sequence model article that he has written before this illustrated transformer. Okay, so visualizing a neural machine translation model, mechanics of sequence to sequence models with attention. Okay, so we went through this paper, and again it had a reference. Okay, here I used Gemini 2.0 Flash thinking capabilities and tried to get what an overview of what the sequence to sequence paper comprises of. Okay, let me give you the overview. Uh, I used Gemini 2.0 Flash. I shared my screen, and it was a good chat with this Gemini 2.0 about what are sequence to sequence models. So sequence to sequence models, they are actually uh, they take, let's say, I'll explain. I don't have the clarity, okay? I'll be very honest, but I do have some overview of what are they. So what they do is they take a sentence. Let's say I have a sentence in I have a dog in English. Okay, they take that sentence if and process it. Okay, process it means what? It will allocate some number, some digit to each and every letter or each and every word to it, and create a fixed size vector. Okay, create a fixed size vector, and then it will do some processing. I don't know, but if you want to translate this to Spanish, it will do some processing here. That vector, mathematical representation of that sentence will work as a vector, and somehow the Spanish translations gets as an output. So Today, to be very honest, I still have this much idea. Okay. So then we further started reading the sequence to sequence paper. And again, there were two research papers links here. One is this, where it has stated about this is the actual research paper that was released in 2014 about what is sequence to sequence and what it is for, what's the actual thing that is being done. Okay. So I see some words like RNN, sigmoid. This is hopefully the sigmoid functions that we are thinking of. Okay, no need to worry about that. We'll dive deep into this. Okay. Okay, so uh, we'll dive. I don't think so. We have to dive deeper into this research paper because, anyways, we are not going to understand this. Okay, so again, one of the reference was this research paper, and the other one was in the model, in the article. Jay Alamar has stated a YouTube video of neural networks, a friendly introduction to RNNs of Sereno Academy. Man, this guy is, you know, freaking best. Okay, I have watched some of his videos. This is great at understanding complex things and explaining complex things. Okay, but obviously this guy has also take has learned from this guy Brandon Rohrer, and this Brandon Rohrer YouTube channel has also a playlist with RNNs and CNNs. So okay, see, so you're seeing it, right? We are getting one step closer, closer, closer. We are drilling it down. We are now at, we started with transformers. We went through sequence to sequence models. We went through RNNs, and now we have CNNs. Okay, so this is the video that we have watched about how actually neural networks work. So, transformers, then sequence to sequence models, then RNNs, then CNNs, and then DNN. DNN means deep neural networks, that is neural networks. Okay, so you might be seeing this sort of red highlighted units boxes. These are the concepts that actually what matlab, these this neural networks have this sort of concepts of sigmoid functions, rectified linear units, derivatives of error, these sort of terms, and that I don't know. So again, we are one step, below to deep neural networks. Let's say if I want to understand if I want to understand neural networks thoroughly, then I have to get a good understanding of these terms. My mind should be my mind should be clear about these concepts like sigmoid functions, rectified linear units, and derivative of obviously derivatives are very important. Again, Brandon Rohrer has taken the inspiration from the OG, and the OG is obviously Andre Karpathy is the beast. Okay, so that guy is also told all of this, and he has an actual playlist. Okay, so we have to give it a shot, even whether we understand it or not. But we have to give it a shot. Okay, this is the Winter CS1, and it is approximately 8 years ago. That is currently we will be in 6 days. Will be in 2025. That is 8 years means 8 years. Wow, that is in what 8 years? 2017. Wow, I was in 11th standard. But all of this are very, very deep. So most of things I didn't understand. Okay, but still, we'll narrow it down. I don't have a time limit. Okay, I this is my supportive thing that I need. And every day with 1 hour on this, focused 1 hour, we can go through. Maybe it will take, even if it takes 6 months, I'm ready for it. Okay, but that way we'll have the clear understanding of what are we doing right now. Okay, obviously something, some concept that has been already taught 8 years back with this much clarity won't be, an overnight, won't be an overnight understanding for me. Okay, so I don't have any problems with it. So again, this was the path that we took, and somehow the last point, the basic point which occurred to me was, first of all, you need to understand what are derivatives. Okay. Okay. So this was the friendly introduction to RNNs. But this video also suggested that if you want to understand RNNs properly, you have to understand what is DNN. That is deep neural networks. What is neural? So both of these videos are same. This Sereno Academy and Brandon Rohrers. But this guy Sereno has taught in a very simple manner compared to Brandon. Obviously, Brandon has taught in a very, good manner, but somehow because of my less less knowledge, less information about all the other things, I wasn't able to understand. But this one, I can say that I have understood about 40 to 50% of what this guy is saying. Okay, and this is what I have wrote about, that ML is telling the machine to reach a goal, but how? By telling the machine that it will reach the goal by minimizing the error, adopting the gradient descent method. Okay, so again, DNN is a subset of machine learning. Machine learning is, what is machine learning, first of all? Uh, Machine learning is just telling the machine to learn. No, no, no. Uh, Let me explain. I did understand this concept yesterday. Machine learning is telling the machine to learn. No, 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 no. Just jokes. But let me just think of it. Um, to learn something. I don't know. Yeah, I'm not able to be very honest. I'm not able to explain this. And this represents that, see, if one cannot teaches slash explains something, then he has not understand then he has not understand that something. Okay, and I accept that I not understand this. Okay, but yeah, this is day one. I need to I need to be uh I don't need to be harsh with myself. Okay, this is day one. If this is the same condition at day 10 or day 20, then I deserve a punishment, or I deserve a slap, but not today. Not today. Okay. To calculate error, the gradient descent, it basically calculates how X action is used. The error function gets calculated using logistic regression. Gets calculated by activation function. Yeah, okay. So here, this guy Brandon Rohrer said that one of the things DNS does is they just there's an step to squash the data, squash the numbers into range of zeros and one, just to compress them. But I didn't know why. So that actually was cleared in this tutorial where it says that there is an activation function. And why do we need to do this? Because it gives us an maybe it gives us a continuous distribution of anything, and that also within the probability of 0 and 1. That is crazy. That is actually so. The thing is that I understood yesterday was is we can convert any data range, okay, any set of numbers in a given data range. Let's say you have a set of numbers from 0 to 1000, 1000 to 2000, minus 100 to 100, any set of numbers into 0 and 1, into the range of 0 to and 1. And that is done by this sort of activation functions. Well, it has a huge use case. Why? Because whenever we are converting a range of numbers into the range of 0 and 1, then we are indirectly setting the probability of this. We are converting. Okay, let's say, uh, let's say there are seven balls of Vibgyor. Okay, violet, indigo, blue, green, yellow, orange, red. Okay, the rainbow colors. Now, each has, let's say, violet has 10, indigo has 20, and so on, up to last 70 maybe. Okay, so that is the thing. Now, the range here is the probability. We need to, if we want to map the probability, you will get it. Okay, we just getting violet balls from all the ball is just violet upon total number of probabilities of all. They divide by all the probabilities of total number was there. Okay, but let's say you have a set of numbers of, let's say you have different speeds. Okay, you have different speeds of a car present at some point, 30, 40, and let's say, let me think of it. Okay, okay, I'm not able to find that example. Yeah, to be very honest. Sorry, guys. Hmm. Hmm. Needs more understanding. Okay, so with that said, I'm sorry if you are disappointed with me, but yeah, this is us right now, and we have to accept. One of the greatest saying that someone has said me is that don't judge yourself in the making. So we are in the making. I'll 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 try to explain all this concept again at the 10. Bye guys. Thank you so much.